Yeah, so we're going to give an update on the Whiteborough Solar project. I'll talk a little bit about the background of it for those that maybe don't know that, and then Richard's going to talk about the specifics of where we're at with it and delve into some of the details. I think it's worth putting it in context. So, Big Solar Co-op, we largely do rooftop solar. We identify rooftops as the key opportunity for new solar. It, there's a lot of rooftop space which needs solar and doesn't have it. But we've always kind of said that there are also potentially opportunities for ground mount solar, but has to be done right. And we looked for a site, and in Whiteborough we found this site. So the site's in Nottinghamshire, which will tell you a little bit more about it. But some of the key things that people don't like about ground mount solar that we're also concerned about, perhaps, is scale. So some of the sites being built at the moment are very, very, very big, and they cause a lot of consternation because they take over landscape. So we weren't looking to work on that kind of scale. We're looking for a one field site. Um, there's concern about taking agricultural land out of usage. And so we were looking for a site where there wasn't a competing land use that was of that sort. So we found this site, Whiteborough, which was an open cast mine until the 60s, coal mine, and has since been used for very rough grazing, mostly for horses. We wanted to also see if we could take forward some of our ethical sourcing work on the site. And so we've planned this project to work partly with second life panels, which is as far as we know, it's a UK first, and we'll talk about that a little bit more. And the other thing is, when you're in a place like Houthwaite, it becomes very apparent that you're in an area which is well, it's an old open cast mine, and so you're almost automatically in a place where there are quite a few people in fuel poverty. Is there a way of connecting what we do with solar to a local tariff, maybe, and making energy cheaper for people locally? And the short answer for many, many years has been no. That's starting to open out a little bit. And so we've signed up to Unity's um, club, which enables us to potentially at least provide cheaper energy to people potentially locally. So it's an emergent area that's not up and running and ready to go, but it's another string to our bow that we're pursuing as fast as we can. That's a good mixed metaphor. Um, I think that probably gives an overview of what we're about there. I'll pass over to Richard. Richard, give you an update of how the project's going, and then we'll go to a Q&A. We're recording this part for those who can't be here, but we won't record the Q&A. If you've got questions, please feel free to put them in the chat or ask them live afterwards. Rich, over to you.
Okay, thank you. Yes. So I'm going to share my screen. Um, and hopefully that's worked. Yeah, any thumbs up there? Yeah, good stuff. Nice one. All right. So, with apologies to everyone who's heard this a few times, I am going to recap from the beginning of the project. So, if you attended either the session we did at the big solar gathering in October last year, or indeed the update webinar we did in March, my apologies to you. But yeah, if everyone in unanimous single voice yells at me not to do this, I will cease. But for the meantime, a recap on the site. As John says, this is a former open cast coal mine. It was active until about the 1960s. It was closed, it was remediated. There's the remains of an old railway line servicing some of the many coal mines around this area at the sort of foot of the hill that slopes down toward it. And as John said, it has been used for grazing. It's very low quality land. It's very clayey. It's a lot of rubble in it, and we actually found out what that really means to say it's a low quality land during the project. And then in about 2014, this project arose. This is back in the era of feed-in tariffs when you could get paid a subsidized rate for exporting energy. This project arose, a company called Raw Energy proposed building a solar farm on there. It was a small one. I think it was only 2 megawatts at the time, and that was brought through planning successfully. But then the project stalled because of a combination of the removal of the feed-in tariffs and unfortunately the death of the landowner. So that sort of then left it on a back burner. Caliva took it over. A big solar co-op bought the project in 2023 in a sort of a mission to get things unstuck. We appointed contractors in 2024, raised capital, as you're probably aware. They were really quite a surprisingly successful, outdid our expectations for the capital raise. And we broke ground last year, and this year, hopefully, well, no, this year we are imminently, not hopefully, imminently is the word, going to energize and start getting that income from the solar, which is abundant at the moment, albeit tempered by the heat, as John said before. So up to October 2025. So this was the point of if you saw the presentation I gave at the big solar gathering in October 2025, you'll see we did this. At that point, we'd done basically the kind of the setting out the groundwork, the prep, ecological groundwork, putting the fences up, getting the marking out with the very sensitive GPS location, get the welfare going, that kind of thing. Uh, and and by March, we'd got a lot further than that. The pilings had been done. The solar panels were up. The electrics were being done. They weren't quite completed at that point. The grid connection had been done as well by that point. So that's the bit where, the good people of the area have to tolerate the road works and the temporary signals, traffic lights in the area. That was all done very, very efficiently, actually, although not without one or two mishaps on their part. But happy to say nothing caused by our contractors, but just other infrastructure around the place that was getting on a bit. The DNO substation went in, and we had dug about an 800-meter long trench for the high voltage 11 kilovolt connection from the solar farm through the farm to the substation, which is by the road. And also, the other thing that you may remember from the March presentation is that we had a tough winter on site. We really struggled with the ground conditions. It was absolutely record-breaking amounts of rainstorm. Yeah, three named storms passed by. I was actually on site for one of them, and the place turned to absolute mush. And this is when you realize actually, a good site where there's that good sort of history of vegetation and root structure in the soil is worth a lot. And when it's really just clay behind a couple of centimeters of topsoil, you very quickly get through to a condition where your diggers are getting stuck and having to be pulled out by other diggers. And the photo on the right here, those are my legs, and that's actually on a track that we'd had made up. So we'd paid to make up a track, a nice area of hard standing, so that we could get lorries through it. And then by February, it was that deep in mud. So we had a hard time, and there's no doubt that our timescales suffered from that, and our contractors suffered from that. Some of them kept on working stoically, and were very really impressed us. Some of them. However, happily, everything turned around. It finally dried out in March, and we were able to sort of redo some of the roads. We had this nice, yes, you can see the same site there with what looks like a solid road. It was a pleasure to behold, really. And then you could walk in there, in your slippers, really, and get to the site, get to where the transformer had to be laid, where all the business end was going to go on, which had been, it had been a no-go area for the best part of a month and a half, really. So that meant finally we were in a position in April to have the transformer substation dropped onto the site. So this was a whole module arrived pre-formed from a warehouse fairly nearby. It was set up. It was commissioned in a warehouse fairly close. So it had a relatively short journey to the site, but it was a very very tense day of getting this in. It had that's 100-ton crane you can see in that picture in the top right. Absolute beast of a thing. Had no idea we were going to need something that's quite so large as that. 16 tons, they estimated the weight of that transformer was. It's a little bit less than that in the event of the thing, but yeah, it certainly it dealt some punishment to the site, but the site took it happily, and transformer is there, and is even now being kind of wired up. The final sort of bits of wiring and commissioning are happening even as we speak. So that was a big step forward. And since then, we've had a lot more work. We've had the second customer substation has come in. So on these two green boxes, the top right, the one on the left belongs to the National Grid, NGED, National Grid Electricity Distribution. The one on the right is ours. We've got CCTV poles gone up at the around the site as well, ducts and all this kind of stuff with little pull ropes going through. So that's going to pull through the little cables, the sort of duct grade Ethernet cables that are going to connect up the CCTV system, and the inverter station top left. That photograph was taken just a couple of days ago. The site still isn't very pretty, but that's in waiting to be sort of backfilled and smoothed over now that the wires are all down. So that's pretty much what it looks like about now. Yeah, as I say, the transformer's being wired up, commissioned, and the meter has been installed. There's a picture of that. So that was another thing which was surprisingly difficult to achieve. And now we are at the point now where we're waiting the DNO to come in and give us a once over and then flip the switch. So that we should hopefully have energy have energy going to our transformer. Maybe end of this week, more likely by the end of next week. And then from that point, it's just a case of having to go through the DNO's process to sort of make sure that everything we've done works as it should do. The witness testing, G99, and we've also, I don't know if you may remember from earlier presentations, we're in an area where there is active network management, which means there are transmission level constraints, which mean that we might have to modulate our generation according to signals from the grid. So that also needs to be tested. But happily, that can be tested once we're going, because at the moment we're only building the first phase. We've only built the part of the site on the right hand side. This is what you can see here, and that's 5,200 Meyer-Burger panels, maximum capacity of 1.976 megawatts. So we are currently within our grid limit. The idea of this was that we have a constrained grid limit, but we are going to overload it. We have a very high AC-DC ratio, and that's partly because we're going to be using second-hand panels, as John said. And so we're expecting them to have degraded. So in order to get as much juice as possible through that 2 megawatt limit, we're going to be having a high overrating it on the DC side. Lots more panels. So the actual nameplate values of the panels, it's going to be more like getting on for 3 and a bit megawatts, maybe getting toward 4. We'll see. But so we're going to lose some of that peak generation, but we should get overall more energy through that constrained pipeline. So that is phase one is imminently going to be up and active, which will be a great day, and there will be corks popped when that happens. But we're already on with phase two. We are preparing that. As I said, we have a target of about 1.5 megawatt peak speed. It might be a bit more, might be a bit less. We'll see. You can see this drawing in the top there. We have the right hand side is done, and these multicolored sections are all the different areas allocated to different inverters. So we have 11 inverters that are connected up, ready to go, and we have 9 inverters left to have panels ascribed to them. So far we have secured about 600 kilowatts of generation, and we're very pleased to be able to say that we have got that. We've got that actually. You can see it here being loaded up onto a lorry and taken. That's in our warehouse now, and we've got about that's 400 to about 240 already in storage, and we've currently got in negotiation for about another megawatt. So when you do the sums, that's a little bit. 600 kilowatts is a bit. It's not very generous for 4 inverters. It's too much for 3. So we're in a situation now where we're looking at, okay, well, can we mix and match different panel types on the same inverter on the same MPPT, if anyone knows what that means. But yeah, basically on the same input, can we mix and match? What are the implications of that? How many? What are the and doing a lot of sums and a bit of engineering around that. And we're anticipating, as I says there, that we're going to be able to install that before the weather turns against us this year. That engineering, that's basically R&D, and we have got some funding from the Great British Energy Community Fund to do a stage 1 feasibility on this whole Second Life project, and that's going to be coming to an end at the end of August, and that will basically allow us to do the analysis of the data. So we've got generation data from panels that we've used. It's allowed us to do a lot of. We've partnered with an organization called Solar, to do the analysis of the generation patterns of those of those panels in the past, and also to do some testing, some sample testing, flash testing of the panels to see what they generate now. The result of that has been very positive, and we're very confident about these panels, although they are a bit mucky, and we will have to do a bit of cleaning work when we get them in situ. But again, we're developing plans for that as well. And also this whole method of transport and logistics as well. You see that there's so the panels at the top is exactly what we're trying to avoid. This sort of the pictures at the top is what we're trying to avoid. This is how panels, when they're decommissioned, will typically be stacked. They'll be on a pallet. They'll be transported. They'll be shaken around. They might be strapped. The straps might break. This is stuff that we've seen that Resolar has seen when they've basically been given panels that have been decommissioned. They've arrived like this and they've been junk. So that's why the two pictures at the bottom is how we've done it. We've had these pallets, these stillages with the poles where they stack up vertically. They were custom made for this. And you can see on the bottom right, we've got a very space efficient way of getting them stacked up too tall on a flatbed lorry. So that's worked really well. As I say, we did a bit of manual restacking of those. It was very easy to do it. They were stacked up in record time. I mean, by the time I got to site that day, they'd already, even the people on site had done it without us. So, it was really wonderfully easy process. And again, we'll be writing that all up in part of this report, very much with the intention that other groups can learn from it, and we can promote the idea of Second Life Solar with all the wrinkles that it adds to the project, but with the potential benefits as well. So right, that brings us bang up to date. So I'll hand back to John. You're muted there, John.
Yes, thanks, Rich. Yeah, so we're bang up to date on that. As Rich said, we're awaiting the grid people to come and check that it's all good for that first phase, and then we're assembling panels for the second phase. And we're not sure, but we sort of feel like we might be the first solar park in the UK to use second-hand solar panels, or at least to do it in this kind of manner where we're trying to do it responsibly and with a decent amount of testing, and as a bit of a beacon for other people to think about solar panel reuse and ethical sourcing overall. So I think that's it from us. It would be great to move to. We've probably stop recording now and go to our Q&A and see what sort of questions people have.